So we're going to start by looking at Madasp question 1, which asks us to calculate the correlation coefficient between the number of maths teachers, x, and the number of burglaries committed in a given town. Now, as you can see, you've been given the data for 1, 2, 3, 4, 5, 6, 7 towns. For the 8th town, H, we're asked in the later part of the question to estimate what the value of that would be using a linear regression model. So we're going to start by just looking at these first 7 towns. So we're going to need to enter that on our calculator. So I'm going to press the menu button on my calculator and then choose option number 6 for statistics. I'm looking for a linear regression model, so it's the y equals a plus bx, which is my linear regression model, option 2. And then it's going to ask me to enter my x data and my y data, so I'm going to just enter that data there. So I've got 35, then 42, and so on. So I should have all the data entered in pairs as far down as my last one, G, which was 39, 30. Notice my frequency for all of those is 1. I'm then going to go to the option menu now that I've saved my data into my calculator, and I am looking for regression calculation. So that's where I find both the regression equation and the value of the correlation coefficient. So that's option 4. And that's going to give me a useful set of answers. I'm just going to write these all down to 3 significant figures. So I've got y equals a plus bx, and it tells me that a equals 15.1. B equals 0.408, and R equals 0.792. So my value here for question A, correlation coefficient, R equals 0.792. And it asks me to interpret the value. Well, it's positive, it's quite a long way away from 0, so I can say there's a positive correlation. Between number of maths teachers, number of maths teachers, and number of burglaries. Now asks me to do a significance test as to whether or not that is a real positive correlation. So first thing I'm going to do is look at my statistical tables and find out what the critical value of R is. Notice it's 5% significance level and it's evidence of positive, so it's a one-tailed test, and it's 5% and n equals 7. So I'm going to look on my tables to find the critical value for R. So if I look on my table here, I've got n equals 7, I'm looking at 5%, and the critical value is 0.6694, it's that value there. So now all I need to do is compare the calculated R value with the critical R value. So 0.792 is greater than 0.6694, so it's closer to 1, which means that there is 5%. There is evidence of positive correlation. Of 5%. Okay, so it's then asking, are maths teachers likely to be responsible for burglaries? Now this is a fairly common misconception, and it's asking you to tackle that, and the answer here is just essentially to say that correlation does not imply causation, so not necessarily true. Correlation does not imply causation. And if we think about why we might see results like this, it's perfectly likely that we would, but you would, for example, expect bigger towns to both have more maths teachers and to have more burglaries. So it's much more likely to be associated with something like the size of the different towns, so we need to be careful with those correlations. The last part E, asks us to use our linear regression values to estimate the values of k for town H. Well, we know that the x value here is 40. We've got the parameters for our linear regression model up here, so I'm going to just rewrite those down here. I can say that y equals 15.1 plus 0.408x. We know that x equals 40, so y, given that x equals 40, equals 15.1 plus 0.408 times 40. That gives us an answer of 31.42. For a question like this, I would round it to the nearest whole number, so it gives you 31 to the nearest whole number equals 31.42. 31 to nearest whole. So you'd expect there to be 31 burglaries in a town with 40 maths teachers.